All right, now that we've got all of our properties down for our exponents, let's start working with it. And we're going to bring our roots into play and how they relate. So first of all, if we look at a problem like this, normally we would just, square root both sides, and we say that x would equal, plus or minus radical 7. Or if I took the square root of 7 on a calculator, I get about, 2.6, about 2.6. Okay, so another way we can look at this, and which this is our mentality that we have to start getting to, is that to get rid of this squared, what could I take it to? What exponent could I take that to? Well, I want to get, x to the first power. We talked about this the other day. So 2 times what gives me 1? Well, 2 times its reciprocal, so 1/2. And if I take that side to the half power, I got to take this side to the half power. Well, taking 7 to the 1/2 power, isn't that the same thing as square rooting it? Let's try it. 7 1/2 power. Same thing. I get the exact same answer. Okay, so square rooting and to the 1/2 power is the same. And the reason why that is because in our square root, there's really like an imaginary 2 that's out, because it's the second root. And it's really 7 to the first power. And that's where that 1/2 comes. So if I looked at these without using a calculator, let's just rewrite these. Okay, we won't actually do it, but let's just go back and forth. Could I write this as a radical? Sure, this would be the square root, right, of 12. That'd be the square root of 12. So I could go either way. What about this other guy? Well, let's just think. Is this taking negative 25 to the 1/2 power, or is it taking 25 to the 1/2 power and then negating it in the end? Yeah, that negative sign is out front. It would have to be in parentheses to include it, and that wouldn't work anyway. I could test it on a calculator, but in this case, this would be negative out front and then radical 25. And the 2 would be out front here, and the 1 could either be in here or outside, either way. All right, we glanced at that the other day. And let's just double check that. Let's just make sure. So if I took negative 25 to the 1/2 power, I get negative 5, right? Because the square root of 25 is 5, and the opposite of that is negative 5. If I had it in parentheses, would it work out? It shouldn't. There we go. Doesn't work. Okay, so let's just quit that. All right, so hopefully we're getting the idea here. So when I get to something like this is the reason why we want to do this, is because I just can't write a square root sign now, because this would be the third root. So to get rid of this cubed, right, we have to take it to its reciprocal power, to the third power, which means I have to take this side to the third power. So x to the third, 1/3 is x, right, because 3 times 1/3 is 1. We don't need to write that 1 up there. And then 64 to the 1/3 power, or I'm thinking of what number to the third power gives me, 60. Sometimes you can think through this mentally. Well, 8 times 8 gives you 64, but also 4 times 4 times 4 gives you 64. So sometimes people can see, think through this mentally. Other times you're going to have to bust out your calculator and go, 64 to the 1/3 power. 4. And what I like to do when I try to do this mentally is I think through, like, what numbers could I multiply by itself to get 64. I think about 2. 2 I could. 3 I can't. 4 I can. 5 I can't. 6 I can't. 7 I can't. 8 I can. And then I think about, how many times does it take to get there? Well, 8 times 8. So that's 8 squared. 4 times 4, 3 times. And then 2 would be quite a few times, right? I think that would be 2 to the 6th power. So hopefully the more you work with exponents, the more you can kind of think through these mentally, and you won't have to rely on your calculator as much. All right, so let's try to rock through these mentally without using our calculator. All right, so first of all, we got a negative exponent, so I need to flip that and put it on the other side of the fraction. So it's, really that over 1, so I'm going to flip those guys, and it becomes positive. This is saying, what number to the third power is really 8? Well, hopefully we can realize that it's 2 to the third power is 8. So I'd have 1 over 2, 1/2. So it's really asking for like the third root of 8. So what number times itself 3 times would give me 8? So 2. All right, going over to this blue guy here. Well, now this is a negative base, right? So I'm not flipping anything. The other one had a negative exponent. That's why I flipped it. And it's just saying what number times itself 3 times will give me negative 27. Well, you got to think of what multiplies to negative 27. Negative 3 times 9, and I could break that 9 into, negative 3 times negative 3. So there we go. I have negative 3 to the third power gives me that. So this would be the third root of negative 27 would be negative 3. And I could go and check all these guys. So negative 27. And why is it negative? Because a negative times itself 3 times would give me a negative, so I know it has to be negative. All right, so this is going to take some time. So it might take a little bit to get to that mentality of how to think through this mentally, but we have to get there. And like I said, what numbers times itself could give you 27? Well, the only one I can think of is 3, right? Nothing else would do that. Whereas I get to 16 here, just know that this negative sign is out front, okay? So don't worry about that negative until the very end. And then I just think, well, 2 times 2 times 2 times 2 gives me 16, and 4 times 4 gives me 16. And I'm looking for the one that takes 4 times to get to 16, right? The fourth root. So I'm looking at this one, right? So 2. So this would equal 2, and I have that negative sign out front, so it really equals negative 2. And if I look at the next one, well, what happens if I took this last one and multiplied it by 2 one more time? Now I'm at 32, right? That's like the fifth root, but I have to deal with this negative sign first. So let's bring it to the other side of the fraction, 32 to the positive 1/5, and that would be 1 over what we just said. The fifth root of 32 is 2. Right? And all these I can check on my calculator, but you're going to be expected to do these mentally. You got to be able to think through, what times itself could give me 32, what times itself could give me 16 and 27 and 8. So we got to get used to those things. All right, so here's our rule. Exponential form is written as a fraction, x to the m over n power. If we write it in radical form, okay, the main thing is whatever in the denominator, that's like the root that we're taking. And whatever in the numerator, that's the exponent that can either go on the inside or the outside of the radical. Either one is just fine. It does not matter. Okay, so for example, if I were to rewrite some of these guys, so this would be the cubic root of 27 squared. And sometimes it's like, should I put the 2 on the outside or the inside? What would make it easier? Well, I'd put it on the outside in this case because I know the cubic root of 27. What times itself 3 times gives you 27? Well, 3. So this guy becomes 3, and then I still have to square that to give us 9. So this stuff you should be able to do mentally as well. All right, let's rewrite this next one. So 100, and this is to the second root. And where should I put that 3, on the outside or inside? Yeah, let's go outside, because I know the square root of 100 is 10, and that to the third power is 1,000. All right, now let's combine some negative exponents and fractions. So we'll kind of fly through this here. So this first one, well, it's a negative exponent, so I got to put on the other side of the fraction. So it's really 1 over 8 to the 2/3. And then you can hopefully start getting used to, okay, what's the third root of 8? Well, that's 2, right? 2 to the third power, and I still have to square it, and that's 1 over 4. Okay, so sometimes you can start doing these mentally where you don't have to rewrite, okay, the third root of 8, that's 2, and then square that to 4. So the more you do, the more you get used to this, okay? So that's 1/4 over here. So let's deal with this negative fraction first. So put it on the other side. So negative 16 to the 3/4, positive 3/4. Remember this negative sign's out front, so we'll just do it at the end. So the fourth root of 16 is 2, and 2 cubed is 8, so I got 1 over negative 8, or negative 1/8. Down here, flip the fraction, right, because I got a negative exponent. So I got negative 27 to the 4/3 power, and then we take the third root of negative 27. So what times itself 3 times gives us negative 27? Well, that's negative 3, right? Negative 3 times negative 3 times negative 3. And still got to take that to the 4th power. And then we get 1 over 81. And lastly, negative exponent, so flip it. So I got 1 over negative 9 to the 5/2. Well, the square root of negative 9, oh, can I do that? I don't know if I can do that. So let's actually type this one in, all right, because can I take the square root of negative 9? A number times itself is not going to give me a negative, so let's just double check that one. Parentheses, negative 9. Doesn't work. Okay, so this one does not work. There's no answer for that one. No answer. All right, so we're getting good at this. So when they get it put in equations, we can solve these two different ways. Okay, the first way over here is, well, it's the fifth root. So just think about when I had, a problem like this. How did I get rid of that square root? We squared it, because why? Well, it's the second root. So what do you think I would do here? Yeah, we would take it to the fifth root. I would just take this to the fifth power, which means I have to take the other side of the fifth power. And then these guys cancel each other, and we're just left with x. And then 6 to the fifth is 7,776. The other way to do it is to rewrite this guy as a fraction exponent. So that's really x to the 1/5 power, right? Because the 5, this is the denominator. And there's an imaginary 1. We don't see it, and that's the numerator. So I could rewrite that, and then what would I have to do? Yeah, I'd have to take that to its reciprocal power, which is 5, and which means I'd take the other side of the fifth power, and there we go. So either way works, whichever one you're most comfortable. So over here, let's do this both ways. Let's look at this one both ways. All right, so to get rid of this fourth root, I could just take it to the fourth power. Whichever I do to one side, I do to the other. So now I had x cubed equals 160,000. And then to get rid of this third power, I'd have to take it to the what? It's reciprocal, the 1/3 power. So I'd take the other side of the 1/3 power, and x would equal, now this is where you have to use your calculator, about 54.3. So get my little squigglies here instead. If I did it the other way, I could rewrite this as a fraction. So I could say x to the 3/4 power equals 20. Well, then it's just one step, isn't it? I just have to take it to its reciprocal power. So whatever I do to one side, I do to the other, because I really want x to the first. And then if I type that all into the calculator, I should get the exact same answer. And there you go, whammy, 54.3. So it works out either way. So whatever you like is just fine. I usually like changing it to a fraction, because then I can do it in one step. Let's finish with the story problem here. There were 8 frogs in a pond. If their growth rate is exponential, and there were 360 frogs 23 weeks later, how many frogs will there be in 32 weeks? So when it says exponential, we knew that we're using our exponential equation, right? And our exponential is, our initial or our starting value. And then this is like our new value. And this would be our b, right? What do we know about the value b? That's our common ratio. And then x is usually, when it's in a story problem, it's usually time. So in this case, we got weeks. So what should I plug in? Well, I know in 23 weeks, that would be my x. It started at 8, so this would be my a. And it went to 360, so that would be my new value, the y. So I'm going to plug those values in. So 360 for y equals 8 was my initial, times b, which we don't know. We don't know the common ratio. And to the 23rd power. Okay, well, how do I solve this now? Well, we always got to get our exponent, this whole thing by itself. So how do I do that? I got to divide by our 8 here. So we'd get 45 equals b to the 23rd power. And then to solve for b, we got to take it to the 1/23 power, right? Take it to its reciprocal, which means I do it to the other side. 1/23. So b would equal about 1.18. So round to a nice number. Since I have a 9 here, 1.18 would be a great number. So we'll go 1.18. And now let's rewrite our equation. So our equation would be y equals our initial, which is 8, our common ratio, which is 1.18, to the x power. And now it's asking, well, how many frogs will there be in 32 weeks? So I'm going to plug that 32 in for x for my time. So y is going to equal 8 times 1.18 to the 32 power. And just remember, we can never multiply before exponents. So exponents always come first. Otherwise, just type it in all at once, and then you won't have to worry about it. So that's what I'll do. I'm going to go 8 times 1.18 to the 32 power. And it should be more than 360, right, because it's more time. And that works out. So 1,597 frogs. So boy, exponentially, that gets big fast, right, doesn't it?